So as it turns out, we really didn't need to use the a notation for derivatives. We can think of the derivative as a function of x because as x changes, the slope of the tangent line changes as well. As you can see from this graph over here, if I just use different x values, then yeah, at every x value, there's going to be a different slope. So we can begin to think about the derivative as, like I said, a function of x. So to find the derivative this way, just using x instead of a, is just the same as before. So let's just go through this. So the derivative function for f of x equals 2 over x would be the limit as h approaches 0 of, now okay, f of x plus h is 2 over x plus h. F of x is 2 over x, and this is all over h. So complex fraction, this means we're going to use the method that we've been using before, and that is multiplying by a form of 1, which means multiplying by x times x plus h, and then rewriting so that we have the limit as h approaches 0. And again, notice I'm keeping the limit notation there until we actually substitute the 0. It needs to stay there. So my denominator is going to be hx times x plus h. Remember, we leave that in completely factored form because that's part of the simplification process. So distributing x times x plus h to each of these terms, in the first term, the x plus h's are going to go away. So that's 2x. And in the second term, the x's are going to go away. And we can't cross anything out yet because the numerator is not completely factored, nor is it completely simplified. So we're going to go the complete simplification route. And just off to the side here, I'm going to write this as 2x minus 2x minus 2h. So that means the numerator simplifies to, whoops, got to write the limit down. I almost didn't follow my own words. Negative 2h over hx times x plus h. And at this point, notice we have a common factor of h. So that goes away. So we have limit as h approaches 0, negative 2 over x times x plus h. And now it is safe to substitute 0 for h. So we have negative 2 over x times x plus 0. X plus 0 is x, and x times x is x squared. So right there we see, given a value of x, the derivative of this function 2 over x is negative 2 over x squared. So what that means, I'm just going to pick a couple different values of x. I'll just do 1, 2, and 3. So that means that this is negative 2 over 1, negative 2 over 4, and negative 2 over 9. And if we go back up to the original function, it does make sense when x equals 1, let's say this is 1 right here, it's a pretty steep negative slope. And as x increases, that steepness goes down. We had negative 2, then we had negative 1/2, then we had negative 2/9. So as x increases, these tangent lines have less steep and less steep slopes. So the result does seem to make sense. So there's another example of finding a derivative function. There will be more. I thank you for watching and watch out for more videos.